There's never been a more pressing need to reduce our energy costs and carbon emissions. This has resulted in a palpable rush to seal our homes from the cold. We now, for the first time, as building designers, contractors and homeowners, have to think about the effects of our actions on indoor air quality and how to balance this with our energy saving goals. This applies not only to our homes, but also our offices, schools and healthcare facilities. It is now a fact that in many cases the humble wall vent alone may no longer meet these needs, and while more advanced technologies like heat recovery can, it is at a cost. There is a technology that does meet the need for a simple, cost-effective and practical solution, while also meeting the imperative to save energy and manage ever more airtight buildings. It's called DCV, Demand Controlled Ventilation, and one company, Aereco, has been at the forefront of this for almost 30 years. More than 25 years ago, by understanding the link between indoor air quality and humidity, Aereco invented the humidity-sensitive nylon strip, and today, Aereco are the world leaders in demand-controlled ventilation. So what is DCV? Almost everything we do in our homes, such as cooking, cleaning, washing, and even breathing, produces humidity and therefore affects indoor air quality. This is why the humidity strip is at the core of what we do. As humidity rises and falls in the room or building, this humidity-sensitive strip is able to open and shut grills accordingly and control indoor air quality. It enables us to simply and effectively control the volume and movement of air into and out of rooms based on the actual need. As the principal driver for indoor air quality is us and our activities, building and system designers have ultimately no control over indoor air quality. Therefore, a fixed ventilation system, such as a simple hole in the wall, or a more advanced heat recovery system, will both at times overventilate, leading to energy waste, and underventilate, leading to poor indoor air quality. Because demand controlled ventilation automatically matches the rising and falling air quality demands of each room, minute by minute, it saves energy, but also secures good indoor air quality. So what makes up a typical demand-controlled ventilation system? Commonly, DCV, demand controlled ventilation, is used in conjunction with a centralised mechanical extract system. Simply, this is a fan that is ducted to the wet rooms in the house, like bathrooms and kitchens, and continually extracts air from these rooms. The resulting effect is that the air is pulled through the house and ultimately fresh air is drawn in from outside. By adding demand-controlled grills with their humidity-sensitive strips to this system, the amount and direction of airflow is now controlled in an energy-efficient and air quality-focused way. There are 4 component parts to the typical DCV system. Air inlets that provide fresh air to rooms like bedrooms and living rooms in a controlled way. Extract grills that extract stale, damp air from rooms like bathrooms and kitchens, also in a controlled way. Ducts that take this stale, damp air to a central point, and at this central point, a special fan that exhausts to outside. Inlets come in 2 types, wall vents like this and window vents like this. Both have humidity sensitive strips in them. The wall vents simply need to be fixed over a hole in the wall, the same as the traditional wall vent. The window vents are fixed to a window frame and replace the traditional trickle vent. They do not require any form of power or control and both respond in the same way to humidity in each room. All our extracts come in the same platform, simply coded the BXC, and are typically fixed to a ceiling or wall. Inside, they will have a humidity sensitive strip, a presence detector, or both. For example, with an extract in a kitchen, the humidity strip will suffice. But in a bathroom with a toilet, both the humidity sensitive strip and the presence detector are typically used. Attached to each extract grill is a duct which is routed to the central fan. The extract grill will then react to the indoor air quality and adjust its extraction rate accordingly. Because the fan is separate to the grill, there is little extract noise. Maintenance of both the extract and the inlets require only a simple wipe down from time to time. We have a choice of 3 fans depending on the house size and number of extract points. They are all designed to work with and react automatically to extract grills. In effect, they speed up and slow down by sensing the volume of air flowing through the extract grills. This means we can extract very effectively when the pollution is high, but save energy when less ventilation is needed. They are very quiet, about the same as a desktop PC, using the same amount of electricity as an energy efficient light bulb. They are also easy to maintain, with no filter changes, requiring only a very simple wipe down or brush down, as with the grills. The fans may be installed in a variety of locations. Together, the fan, extract and inlet grills make a DCV system. Aereco was founded in 1984 by a former scientist and engineer at the CSTB in France. We have since then continually been at the forefront of understanding both ventilation and indoor air quality. Operating in 25 countries worldwide, our components have now been installed in nearly 3.5 million homes. In fact, since our foundation, we've manufactured 16 million of the humidity sensitive strips and are so confident in their reliability and accuracy, we've given them a 30-year guarantee. Aereco's demand control ventilation systems don't care whether your building is big or small, airtight or not, or how many people it has living in it. All the system wants to do is manage indoor air quality in the most efficient way possible. That's what demand control ventilation is all about. For homeowners, it quietly, automatically and without a fuss secures indoor air quality, saves us energy and ultimately money.